Hi guys, and welcome to More About Exponents. Today we're going to learn how to divide exponents, and I think you're going to see it saves you a lot of time in the long run. Okay, so today you're working on quotients of powers. You're dividing powers, and the key thing to remember is they have to have the same base in order to do this. So if you have 4 to the 5th divided by 4 to the 2nd, another way to think of it is 4 times 4 times 4 times 4, lots of 4s, over 4 times 4, right? Now, you know when we have fractions, if you have the same factors on the top, same factors on the bottom, you can cancel it out, right? So we could actually cancel out those two, we'd be left with a 1 down here, so we'd end up with 4 to the 3rd. Now, when you compare the exponents, what do you notice? When you're dividing, you subtract the bottom from the top. So it's the same as 4 times 5 minus 2. Okay, so that's how we can handle exponents with the same base. So now what if we don't have a numerical base? What if we have a variable for a base? Same thing applies. It would still be equal to h to the 7 minus 6th power, or h to the 1st, which would just be a standalone h. Okay, now imagine we have some more operations on top. We have 4 to the 4th times 4 to the 2nd. So let's go ahead and simplify this and make that 4 to the 6th, because you remember when we're multiplying exponents that have the same base, we end up adding the exponents, right? Over 4 to the 3rd. And then we're going to subtract, so that would be equal to 4 to the 6th minus 3rd power, which would be the same as 4 to the 3rd power. So we're going to try that one more time with a variable here. We have a to the 10th times a to the 7th over, actually it's going to be divided here, a to the 6th times a to the 4th. Okay, now the thing to remember when you multiply, you're going to multiply straight across, right? So you could almost make this line and go straight across and deal with multiplication up there and the multiplication down there. So let's see. We're going to have a to the 17th over a to the 10th. Then we're going to subtract those exponents and end up with a to the 7th. So I hope you guys are seeing this pattern. I hope you're seeing that it's pretty easy. Okay, here's one where we have two different variables. We have an m and an n, okay? So you're going to be able to use the quotient property or divide your exponents for each individual variable. So you can't mix m's with n's, but you can just evaluate the m's together. So 10 minus 1 is going to give you m to the 9th. 7 minus 6 is going to give you just n. So that is your final answer there. Now I want you to look at how you could use this great knowledge to save yourself a ton of time. So you have this situation where you know how big the side of this cube is. So the side is 4. So the total volume would be 4 to the 3rd, right? Now the side of this is 4 squared. So your total volume would be 4 squared times 4 squared times 4 squared times 4 squared. So let's write that out. So it would be 4 squared cubed, right? So you remember we would multiply those. So you would end up with 4 to the 6th. So that's the total volume of your larger square here. And you're trying to figure out how many of the smaller ones fit in there. So that would be 4 to the 3rd, right? So what do you think? When we divide that out, you would have 4 to the 3rd, and that's how many of the smaller cubes would fit in the larger cubes. And that should hold true for any of these situations. Okay, so your assignment for today is 10.3, 1 through 25, odd and 22. And I think you're going to find it goes really fast. So good luck. Bye, guys.